Hello everyone, welcome to the stream. Today is going to be the fifth class, fifth, sixth. I think it's fifth, right? Fifth class, and today we are going to jump into time series analysis and forecasting. So let's wait for a couple of more minutes so that people start joining in. We have the lowest batch strength today, just 5 people watching the stream. Anyways, let's wait for 1 or 2 more minutes and then we'll get started. So far, just to let you know, for people who are complete beginners and completely new to the stream, this is the part 5 of our end-to-end machine learning videos. And so far, we have covered a lot of topics related to machine learning, related to classification, related to regression. Today, we are going to focus on um, time series analysis and forecasting. I hope my audio is completely fine. Can I have a confirmation in the chat box? If yes, we'll quickly get started with time series analysis and forecasting. Voice is good. I'm keeping an eye on the chat window. Cool. Okay, so just to let you know that tomorrow is not going to be the last session on on machine learning. So if you remember, hyperparameter optimization is not taught and feature engineering is not taught, right? So tomorrow we will have a deployment class. So officially tomorrow is the end of the end-to-end classes on machine learning, but I will be giving you a 2 hours video on hyperparameter optimization in the next Saturday 8 p.m. So once that stream is ready, I will let you know the links. And if you just forget that video will also be a part of the machine learning playlist on my channel. Okay. So in short, you will be getting all the videos. Now talking about feature engineering. I already told you that we have a playlist. If I take you back to my YouTube channel, 1 second. If I go to my YouTube channel, if you go to this playlist, right, there is a machine learning playlist. So in this playlist, all of my part 1, part 2, part 3, part 4 videos are already here. Okay. So people who don't have the links to all the 4 classes, you can go to this playlist. Now, feature engineering videos are already provided. These are old videos, but the mathematics does not change. The algorithms are the same, right? So you have to go through these videos because this PCA LDA is not taught in the live classes. So it's a series of videos, part 1, part 3, part 2, part 3, part 4, part 5. So you have to go through all of this. Okay. And only one topic will be pending that I have not covered in this program, which is hyperparameter optimization. Repeating once again, end-to-end hyperparameter optimization video will be live next Saturday at 8 p.m. Okay, so today let's get into time series analysis and forecasting. By the end of this stream, I will tell you what is the agenda for tomorrow. Tomorrow is going to be one of the most important days because I will be onboarding, I will be talking about a use case. I'll also show you how the deployment happens in AWS. So we will be creating an AWS account and we will be deploying our Flask-based application on AWS. So you can follow the same steps and do the same for your own portfolio projects. Okay, let's get started with time series analysis and forecasting. In the meanwhile, let me also open my Miro board because I will be using Miro for explanation. Class rules. In case you have any questions, write it down in the chat box. I will only watch the comments and respond if it is related to what I am teaching. If it is not directly related to what I am teaching right now, we will be taking those comments during the break. Okay. So today we shall be talking about time series analysis and forecasting. Okay. So before we get started, I'm just giving you an idea. Sir, if we want to deploy our ML model in Apto, is just it's not paid. You can but credit card is required. Okay, so you just have to add a credit card. You will get a bunch of free credits. You can practice it, and then once your practicing is done, you have built some confidence in how the deployment happens. You can, you know. Stop your instances, and there will be no bills, so do not worry about it. So with zero cost you can do. Okay, now let's get started with time series analysis and forecasting. First of all, I told you that in machine learning there are two things, right? Especially we have supervised learning and we have unsupervised learning, right? In supervised learning we deal with labeled data. In unsupervised learning we have no labeled data, right? So problems like classification, problems like regression, problems like time series forecasting comes under supervised learning. Under unsupervised comes clustering, recommendation, and all those things. Right? Now, focusing on regression and time series. Regression is by far one of the lowest priority topics. I mean, when you are studying machine learning, you should always deprioritize regression. Please take live session and complete hyperparameter tuning and tomorrow. Now tomorrow is not possible. Tomorrow live deployment itself will take 2 hours. So hyperparameter tuning will not be able to cover tomorrow. Okay. So hyperparameter next Saturday. So regression is the lowest priority when it comes to your learning in machine learning. Classification, time series, these are all the top priority things. Why regression is low priority, and what is the difference between regression and time series data? Let's try to understand. So first of all, this is an overall agenda of time series analysis and forecasting. However, in 2 hours I'll not be able to cover some of these topics like multivariate time series forecasting. I'll not be able to cover. I will be covering rest all the topics: introduction, understanding, pre-processing, exploration of data, univariate forecasting, forecasting performance evaluation, some of the advanced forecasting techniques like Facebook Prophet, Neural Prophet. Again, in depth, I will not be able to cover, but I will give you ideas. Okay. And time series forecasting and practice, we will be having a case study which we will be solving. Okay. Time series analysis and forecasting is one of my first research project. I mean, I started learning data science. My first topic was time series. My first use case was time series, and my first research paper was time series. Like 5 6 years back, literally, I thought of creating a book on time series because I had so much in depth research knowledge on time series. I wanted to create a book, but then I realized that creating a book takes a lot of dedication, and then I could not do this. But it is always my dream in the future. Maybe sometime I will do write a book on some of these topics. Time series analysis and forecasting in 2 hours, it's not possible. Arima and Sarima, yes, they are part of it. Time series in 2 hours is literally not possible. Usually for time series in live classes, I usually take like 10 to 12 hours to complete time series. But as we have shortened down this to YouTube series, we will be trying to give you enough information in 2 hours. But just in case you are interested to enroll for my end-to-end time series forecasting course, you can check out the link in the description. There is a beautiful course of 10 to 12 hours with three use cases, and I'm giving it at 399 INR, 399. Okay, let's get started without spending much time. So, time series forecasting is an important area of machine learning, right? Like when I started my data science course, I'll be very honest with you. Nowadays, time series is a part of all the data science programs. But when I took a program, I'm talking about 8 9 years back, in 2016 I took a program. I'll not reveal the company. I paid somewhere around 35,000 to learn. I did not attend a single class. I did not check any of these videos and recordings. I just paid and I self learned it. Time series was not a part of the program. And then later on, I realized that time series is very, very important. Now, what is the difference between time series and regression? It is the time component that is the most important in time series. And why regression is not the best, I mean, why should we deprioritize regression? Because in industry level problems, in any company you go, companies usually save data in databases, right? When companies are saving the data, there is always a date column. And when you have date as one of the features for a regression problem, the problem statement changes from a regression problem to a time series problem. You must be thinking what I'm talking about. Try to understand the date parameter usually plays a very, very vital role. Now, for example, you are doing a sales analysis, right? Let's say you have some. Now, if you analyze the data with respect to the x axis, which is a date column, you will potentially realize that during every year, during a certain point, there are spikes. So, the time component, the date component is very important because in the future, if you have the similar date, you can easily forecast a similar kind of bump or similar kind of, this kind of graph in the futuristic data, right? But if you take this data into a regression model will not be able to understand this patterns, because for regression, date column is nothing but a simple column. So whenever you have a date column, and that date column plays a vital role in the forecasting of your y variable, basically you can use time series algorithms to solve the problem. So time series forecasting is an important area of machine learning that is often neglected. Yes. Some people also don't call time series analysis as machine learning because it is more of a statistical process. I agree with that because time series analysis and forecasting is not really machine learning. Rather, it's a statistical approach. It's a statistical algorithm. Eventually, machine learning is also statistical algorithm, but yeah, it depends, right? Time series analysis, I consider it as a statistical model, but yeah, it can be considered as a machine learning algorithm as well. It is important because there are so many prediction problems that involve a time component, and these problems are often neglected because it is this time component that makes time series problems more difficult to handle. Okay, now, first of all, what is time series? Now, let's say I have a data. I have a date. Let's say I have sales. Let's say January 2020, the sales was 2 million. Feb 2020, the sales was 3.5 million. March 2020, the sales was 4 million, and so on. You have data till December 20. Now you need to predict for January 21. Can this be considered as a time series data? 100% yes. Why? Because you can see the difference between two consecutive data points is same throughout the data. That means it's a monthly data, right? January, then February, then March, then April, then May, then June, till December. So the difference between two data points is same. If you consider another data set, let's say date and sales. So let's say January 13, the sales was 2 million. January 29, the sales was 2.5. Feb 25, the sales was 3. March 30, the sales was 3.5, and so on. So, can this data be considered as a time series data? If you look at the original data, it will not be considered as a time series data because the it's not having a equal difference, right? The difference between first and the second data point is 16 days. Second and the third data point is somewhere around 26 days. Fourth and this one is around 35 days. So it is not in proper sequence. But can we convert this into a time series data? 100% you can convert. Let's say you combine them to make it a month level data. January, which is, let's say, 2.25, you're taking the average, or maybe you can add it up, 4.5, anything is fine. February, 3, March, 3.5, and so on. Now this can be treated as a time series data. So what I'm trying to say is you can actually make any data a time series data. Okay, and when you have a time series data, it is always recommended that you use time series algorithms. Regression algorithms are not recommended. But eventually, after the end of this theoretical part, um, we will be taking an use case. We will be solving that using one of the classical regression algorithms, and then we will see how time series algorithms are helping us. Okay, so let's get ahead. There are different components of time series. We have trend, we have seasonality, we have irregularity, and we have cyclic. What do you mean by trend? Trend is something like this. If I ask you whether this is an increasing or a decreasing curve, 100% it is an increasing curve, right? So this is the trend factor, whether it is increasing or decreasing. Seasonality is this part where you are able to spot a particular pattern in the data every year. Irregularity is something which is random. Let's say in your data points, you see random spikes, not at equal intervals or not in, you know, every year. You don't see these kind of patterns. It's completely random. That is called as irregularity. And cyclic is something that happens after every cycle. Now, this graph and this graph are same, but cyclic is something like, let's say, in one particular year, every 3 months you see a spike. But seasonality is something like season by season. Okay, every year you have Christmas, right? So every year during December, the sales will go high. That is seasonality. But cyclic is every 3 months there is a spike. So 2 months the business is down, and the third month it goes up. Then fourth, fifth down, then sixth goes up. That is the cyclic behavior. Now these all are the different components of time series. Okay. Now why I'm talking about the components of time series? The reason is very simple. When you solve a time series forecasting problem, there are some requirements. Okay, we need to have the time series data as stationary. Let me let me try to draw the flowchart of a time series model. Okay, so let's say I'm talking about a time series model. See, repeating once again, 2 hours for time series is not enough. I mean, you'll not be become a wizard in time series, but it's good enough. That means after today's class, you will definitely have a better understanding on time series algorithms, and you will also start solving some problem statements. But you will not be a pro, as simple as that, right? To become a pro, you need to spend some time, and time series is a very, very deep topic. A lot of things are there. There are at least 25 algorithms that I can talk about. But today, we are only focusing on two or three different algorithms. That's it. So how does the flowchart happens? Imagine you have a data, you have a date column, and let's say you have sales. Okay. The very first thing is obviously dividing the data into training and test. Okay. Actually, before that, what we need to do is we need to, 1 second. Hmm. Hmm. The very first step is checking the components of time series. Components of time series. Okay. So you can, there are some techniques where you can visualize your time series and you can also visualize your components. The reason behind this is our next step is we have to go for a stationarity test. Stationarity test. Now, stationarity test is the most critical thing in a time series problem. What do you mean by stationarity test? What is stationary? Can, it's a simple English term. What do you mean by stationary? I'm watching the chat box. What is stationary? Stationary means stable, right? Stationary means stable. As simple as that. So, what do you mean by stationarity test in time series? Now, in time series, stationarity basically means your statistical properties should not change, does not change, or should not change, doesn't change over time. And what do you mean by statistical properties? Statistical properties like mean, standard deviation, and so on. That means for a particular data, let's say your data is like this, right? Can somebody tell me, okay, okay, let's take an example, proper example, not like random examples. Okay, let's say I have 2020, 2021, 2022, 2023, 2024. Okay, let's say this is 50, this is 100, this is 150, this is 200, this is 250. It could be anything. Okay, let's take this as a sales. Okay, so let's say my graph is, okay, beautiful graph. Now my question is very simple. What is the mean sales in this block? And what is the mean sales in this block? I don't want the exact number, but give me a range. What is the mean sales in the block 1? This is block 1, this is block 2. The mean sales in block 1 is somewhere around 55 or 60, right? Because the data points are ranging from somewhere around 40 something to 60, 70 something, right? So the mean will be somewhere around 55 to 60, or let's say 70. Okay, what about this block? Definitely the mean will be somewhere around 170, 180, right? So is this graph stationary? This graph is not stationary. This graph is not stationary. So in time series forecasting, your time series data has to be stationary. Why? Because if it is statistically changing over time, it will be very, very difficult for us to predict the future. Now, what is the meaning of stationarity test and what are we going to do with that? Let's try to go ahead with the architecture or the flowchart. Now, stationary test is done. Okay. Let's say the data is stationary. There are two scenarios, right? The data is stationary or the data is not stationary, right? Let's say the data is stationary. First of all, how do we test it? There are some statistical tests. Okay. There are some statistical tests. Krishnadas, if you see, time series analysis has a lot of, if you learn module by module, it's going to be difficult. That's why if you take the entire AI program, I can guarantee you will learn a lot, because LSTMs, using LSTM also you can do time series. But I cannot cover LSTM in time series, because to learn LSTM you need to learn deep learning, right? So data science has a lot of topics which goes from topic A to topic B to topic C. It's like a maze, and then you have to connect the dots. So in my master program, in the AI end-to-end AI program, I have covered a lot of things. Your end-to-end understanding will be done. But if you only take the time series program, it has some algorithms, not all. Okay. Coming back to this, stationarity test is done using, there are some tests. One of them is called as Dickey-Fuller test. Dickey-Fuller test. And another test is KPSS test. So these are the two tests that are done. I will do this test. I will show you how to read the test outputs. So do not worry about this. Imagine your data is stationary. Then what? Then you divide the data into training and test, and you create your model. Let's say model 1, and pass it, and the model will be able to do the prediction. Simple. If the data is not stationary, then what? Then there are some transformation logics. There are some transformations that we need to do. What are some of the transformations? One of them is a log transformation. One of them is double log. One of them is differencing. So multiple transformation steps are there. Okay. So out of these transformation steps, you have to do the stationarity test after transforming everything. Imagine with the log transform data, you are doing a stationarity test, and let's say your time series data is stationary. Then what you will do is, can you directly do the forecast? And is this your final forecast? No, because imagine you have a data set. We'll take a real time example. I will be using this Bitcoin data for today's class. So let's say I'm taking this column. Okay, I'm creating a new sheet. Now this is your original data. Let's say you are transforming them. I will write it down as close hat or close dash, and I'm transforming them to log data, log of this. And similarly I will do it for others, right? Imagine this is your new data. That means this is your transform data. Now on top of this data, if I do a prediction, the prediction will be somewhere around 2.07 or 2.06, right? Now how do we get it back to the original thing? So going back to the architecture, this forecast is not your final forecast. Here you again have to do inverse transformation, and then you get the final forecast. Because you are doing some transformations here, right? So you have to do inverse transformation, because if you don't do inverse transformation, your final output will be in the range of the transformed data, right? But you need in the original scale, right? So anybody has any doubts here? I'll go back to the flow chart. I'll minimize it. Please try to go through this, and if you have any questions you can ask me. If not, I will proceed. So everything is clear, and stationarity tests is majorly used for some traditional statistical algorithms like Arima. So I'll talk about some of the time series algorithms as well. In the space of time series, there are multiple algorithms. Okay, one of them is Arima, which is a combination of AR, MA, ARMA, ARIMA, and there are some other variants of Arima which is called as seasonal Arima, seasonal Arimax. Okay, all of these algorithms are statistical algorithms. They are very, very traditional algorithms. If you ask me, in today's world, we usually don't use these. I mean, at least not me. Many of my time series algorithms are productionized, they are running in production. None of them are Arima because Arima has drawbacks. But can we skip Arima? No. Arima is the core concept because in interviews they will be asking questions related to Arima. So understanding Arima is very important. There are some algorithms, again some statistical old algorithms like Garch. There are some algorithms which is Holtz-Winter, Holtz-Winter exponential smoothing. Okay, and of course there are a bunch of regressors that can also be used, but those are not typical time series algorithms. We have another algorithm called as Facebook Prophet. Now, I have been using Facebook Prophet since quite a long time, almost since 2016 2017, when it was released by the Facebook team. It's a one of my go-to algorithms. Similar to Facebook Prophet, Facebook also released a new year version which is called as Neural Prophet. There is also LSTMs. LSTMs, and again coming on to LSTMs, bidirectional LSTMs, GRUs, and the list goes on. So, if you ask me about my end-to-end AI program, this is covered. This is covered. Garch is not covered because it's very traditional technique. Holtz Winter is also a very traditional technique, so I have not covered because we barely use these kind of algorithms. Facebook Prophet, Neural Prophet, LSTMs, bidirectional LSTMs, GRUs, all of these techniques are covered. Okay, jumping back to our class. As I told you, to test stationarity, there are some statistical techniques, right? Statistical tests are there which directly tells you whether the test is positive or not, as simple as that, using p values. Apart from that, we can also check the stationarity looking at the plots. Looking at the plots is the most idiotic approach, like this. Like if you have a data, if somebody asks you, oh, is this stationary? 100% it is not stationary. Why? Because mean is not same, so it's not stationary, as simple as that, right? So visual techniques are also there, but not recommended, right? Usually we should go for statistical tests or summary statistics. So let's try to talk about the stationarity test. The stationarity test that we will be using in today's class is basically going to be Dickey Fuller test. Okay, so we will be doing Dickey fuller test. And once I go through these practicals, I will tell you exactly what are the how to read the output. Okay. In our Dickey Fuller test, statistical tests are basically hypothesis based on hypothesis testing, right? It is based on hypothesis. In statistical tests, we start with a null hypothesis. There is an alternate hypothesis, right? Everybody knows statistics. Assuming if you don't have statistics knowledge, again, my channel already has 6 7 hours of statistics content. Just go to the playlist, you will find it. Dedicated videos are there, right? So we usually start with a null hypothesis. What is the null hypothesis? That the time series is not stationary. Okay, so the null hypothesis is time series is non stationary. What is alternate? Obviously time series is stationary, right? And then using p values, if the p value is greater than 0.5 0.05, we fail to reject the null hypothesis. If the p value is less than 0.05, we reject the null hypothesis and we assume that the time series is stationary. Okay, so fine, repeating once again. In my statistical test, there are two things. We have null hypothesis, we have alternate hypothesis. The null hypothesis is time series is not stationary. The alternate hypothesis is time series is stationary. So if my p value is greater than 0.05, we accept the null hypothesis. So we accept this. If my p value is less than equals to 0.05, we reject h0 and accept h1. This is clear. This was part of hypothesis testing, right? So this is clear. Let's move into the coding part. Okay, so I don't want to go through all of this, so directly we will go for the coding part. And while doing the coding part, I will explain you um, different pieces of codes. Okay, I have already written down the code for Arima because there will be a lot of time which will be gone in the explanation part. So if I start writing from scratch, we will end up having a huge session, right? So let's first go through a basic example on Arima, and next we will be doing, we will be taking the Bitcoin data and we will be creating a simple application, a simple machine learning model. Okay. So the codes will be a part of the GitHub repository. So do not worry about these things. First pieces of code, I am importing the libraries, and I have mounted the Google Drive. So my data is already in my Google Drive, which is a air passengers data. This is a very basic example, right? So just for the sake of explaining Arima, I'm taking this basic example. Now if you look at the data, it's basically having two things, right? The date column and the number of passengers. So we need to do a forecasting on the number of passengers. We have data from 1949 to 1960. Okay, so here I'm converting my data. So I have just created my month as an index and passengers as my column. I will explain you. Okay, I will do the hypothesis testing here and I will show you. So here the first thing is I am plotting my time series graph. I will take this graph to my Miro board. Okay, now tell me, just looking at the Looking at the graph, learn maths first. Oh, is there a question? Should I learn math before diving into machine learning or try to combine both? Combine both. There is nothing like learn maths first and then do machine learning. It's not like that. The way I have taught in the entire machine learning series, that's the right way. If you are exploring decision tree, first explore the mathematics behind decision trees and then start implementing it. But it should not be like first learn algebra, then calculus, then this, then that, then and then go for algorithms, right? You will not understand. You will not be able to understand where which concept is being used in which algorithm, right? So it's a simultaneous thing, right? So in this graph, looking at this graph, can somebody tell me visually, is there a trend? There is a trend, right? Everybody agrees there is a trend, right? Is there a, I will tell you, Ashutosh, please attend the class and then ask your questions. I have not started with Facebook Prophet, so relax. I'm going to cover. In this graph, statistically it is changing, right? There is a trend, it's statistically changing. So 100% this graph is not stationary. I also see cyclic and multiple stationary, this thing, right? What do you say? Seasonality components, right? So 100% this graph is not stationary. Now, this piece of code is nothing but your stationarity test. Okay. Do not worry about the code, it's not that complex. First of all, I am importing the Dickey Fuller, AD Fuller, augmented Dickey Fuller test. I have created a simple method. Here I am taking the rolling mean, and here I am taking the rolling standard deviation. Now, if you remember, this data is a monthly data, right? And in 1 year, there are 12 months. So that's why I have taken a rolling mean of window 12 and rolling standard deviation of window 12. And then I'm plotting the original time series, plotting the rolling mean, and plotting the rolling standard deviation. Okay. And here is the main code where I'm calling my Dickey Fuller test. I'm called passing the time series, and these are some statistical things. You just have to copy paste this code. What are these things? I will let you know. Okay. What is test statistics? What is p-value? What is the number of lags used, and multiple things. So let me run this code. So my function is ready. Now I'm directly calling my test stationarity on my original time series data. So if you look at this graph, by default, we are able to see a huge graph. On top of that, I also want to take the results to the mirror board and explain there. Okay. Wow. Okay. Now look at this graph. In this graph, the blue is the original line, right? The rolling mean is the red line and the rolling standard deviation is the black line. Forget about the blue line. Only check the red line. Red line is the rolling mean, right? So look graphically, if you see visually, we can also tell that the time series is not stationary, right? So visually, we are able to see and tell it's not stationary. But what about the results? In the results, there are two ways to interpret. Okay. The first way is p-value. What is the p-value? P-value is 0.99. So p-value is 0.99. What was our hypothesis? Hypothesis was time series is not stationary. Alternate hypothesis was time series is stationary. If my p value is greater than 0.05, then accept. If p value is less than 0.5, reject the null hypothesis and accept the alternate hypothesis. So in this case, we are in this category, right? So we can accept that the time series is stationary. Okay. So there are three techniques. One is the visual technique. So visual technique also tells time series is not stationary. The p value technique is also telling time series is not stationary. Okay. How yeah, ho will be true, correct. My bad. And the third technique is you can compare your test statistics with your critical values. Okay, your test statistics should always be less than the critical values. If you draw your critical values, 1% is somewhere here, minus 3.4, minus 2.8 is here, minus 2.5 is here. What is, where is test statistics? Test statistics is somewhere here, right? 0.8. So as this is not less than critical value, again based on this also time series is not stationary. But what do you mean by critical value? Critical value is the confidence. 1% means with 99% confidence we can say that the time series is stationary. With 95% confidence, with 90% confidence, just imagine your test statistics is not 0.81, rather it is minus 2.79. So where this will fall? This will fall somewhere here. Okay, this will fall somewhere here, which means it is better than 10%, but not better than 5 and 1%. So in this case, we can say that with 90% confidence, we can say that the time series is stationary. Okay, but in this case, all of the three techniques, it is not stationary. So going back to my architecture design, going back to my flowchart. Where is my flowchart? So we basically did this and we fell into this category, right? Now we will be doing the transformations. Okay, so let's go ahead and do some transformations. There are multiple transformations. The very first transformation technique is logarithmic transformation. So let me write it down. Transformations. Logarithmic, double log, triple log, and the flow goes on. Another technique is moving average. Another technique is, sorry, another technique is differencing. Another technique is combination of log plus differencing. So there are multiple techniques that we follow, and after every technique we should do the stationarity test. Stationarity test, sorry, ST. Stationarity test. Stationarity test. So after every step we have to do this. So it is a time taking process. So let's go to the code and do some transformation, log transformation. What is log transformation? Log transformation I just showed you, right? You take this data and then you create your new column and just transform it using the log function. That's it. Now this becomes your new data. What is differencing? Differencing is nothing but like this. Let's say the first one will be null, second one will be this minus this. Sorry. Second one will be this minus this. Third one will be this minus this. And so on. This will be differencing. Moving average, what is moving average? Moving average is also like this. Let's say you're taking a window of 3, so it will be null, null, it will be null, it will be null, it will be null. For this one, it will be the average of these 3, average of these 3, and it goes on. This will be average of these 3, this will be average of these 3, this will be average of these 3, and it goes on. So this is also a transform data. So on top of your transform data, you can do the stationarity test and then predictions. And after your predictions are done, you have to do the inverse transformation, right? Inverse transformations are very easy to identify. You can, these days you can take help of chat gpt to kind of do the inverse transformation, right? Let's say you can tell, I have a data frame where I transformed the y variable to log of y. I want to do inverse transformation. Write the Python code. So easily you will get the inverse of log is nothing but exponentiation, right? So numpy.exp, and you will be able to get the original. Let's say you want to do some differencing. I have transferred the y variable to differencing, and here's my code, and then you pass your Python code, whatever code you have written down, and then after that you ask. So based on your prompt you will get the answer. So these days working on inversing transformation is not that difficult, right? So let us go ahead and do some transformations. So here I'm converting the data into log. Now if you look at the data, you can see the format has changed, right? 4 point something, 4 point something, 4 point something. So obviously if you do a forecasting on these numbers, your final output will be 4 point something, right? But your original numbers are like this. So you should take an exponentiation, np.exp, and then you will be able to revert it back to the originals. So as my transformation is done, I'll plot the graph. The graph looks like this, and then I will do the stationarity test once again. So I'll copy this to my Miro board. I will reduce the size, and then I will also take the observations and hmm. Okay, done. So now visually, obviously visually, I can still say that time series is not stationary, right? Because you can see the mean here and mean here and the mean here. I see a trend, right? But it is not like the original graph, but somehow it is better, but still there is, the data is still not stationary, right? So looking at the graphics, looking at the results, what is my p value? My p value is still very high. Originally it was 0.99, right? So now it is better, but it is still not the best. And critical, and the test statistics has also gone down, but still very far away from 10%. So using both these three techniques, we can say that we accept the null hypothesis. And we move on to the next chapter. We will be doing another log transformation. So I'm doing a log on log, right? So let's say this is my data. First step, I'm doing a log. So basically you have to do a log 10 of this. log 10 or log number, let's say this base 2. Yeah, you can do that. My numpy log np.log is basically log base 2, right? Numpy log np.log. np.log is log base 2 or log base 10? I don't remember actually. np.log is log base e. Okay. So I'm not sure how to do log base e in Excel. Let's say I'll give an approximation number so that we can do. Yeah, I see an approximate value. Okay, now this was my first transformation, right? My second transformation is log of this comma this. So you're able to get, right? I'm doing a double log again. After that I can do a triple log and the process can go on till the time I get at stationarity. So that is one approach. Another approach is doing differencing or moving average. So doing double log, I'm able to see my data like this, and I'll do a transformation here, do a stationarity test. I take my graph to Miro, and then I will take my results. So now the results are even better. If you start comparing with the original time series data, obviously the results are far better, right? In the original, the p value was 0.99, then it was 0.42, and now it is 0.22. So we are moving in the right direction. Okay. Similarly, if you look at the test statistics, it is also a better number. So it is very close to this, but still there are some, uh, we still need to do further things, right? So I'll not do further another log. You can take your time and do that. I'll rather do some other techniques. So here I'm doing a smoothing technique. So I'm taking a rolling window of 12, and you take your take your logarithmic data, and then from logarithmic I'm doing a log minus moving average. So it's a bit complex step. First I'm taking the rolling mean, and then I'm doing log minus rolling mean. So now if you do a stationarity test on this data, can you see the p value is less than 0.05? Now we have a stationarity data. The time series is stationary, right? And if you look at the test statistics, it is better than these numbers. So this actually can be called as a 99%, sorry, 95%. With 95% confidence, this particular time series is stationary. Okay, so got it. I'm not taking this. Oh, we can take this to Miro. I'm not taking it. Wasting it will be a lot of waste of time. So moving ahead, there are some other techniques I have done and checked the stationarity test. You can follow this technique. This is a beautiful code where you can actually see your decomposition of the data. That means you can see your original time series data and you can see the different components. So let me run this. So you can see this graph is a very beautiful graph, right? Okay, I'm not taking it. This is the original data, right? The trend is like this and the seasonality is here, right? So finally, going ahead with the Arima thing. So I'm calling my Arima function here. So in Arima, there are two things. In fact, there are three things. One is the okay. First of all, this is a statistical function called as autocorrelation function, and this is another statistical function called as partial autocorrelation function. Visually, using these two functions, you will be able to identify the parameters of Arima. So Arima has three parameters. So one second. So Arima has three parameters. Arima has P, D, and Q. Now P is the autoregressive part, D is the differencing part, and Q is the moving average part. And that's how Arima has different flavors like AR, MA, ARMA. Now, what does that mean? That means if your D is 0 and Q is 0, it becomes a AR model. If your D is 0 and P is 0, it becomes a MA model, and so on. Right? But identifying these numbers is the critical thing. How do we usually identify these numbers? And this is where hyperparameter optimization comes into picture. Okay. Another technique is called as auto Arima. There is a library called as auto Arima. If you take your data and run this model, you will eventually be able to find the best p value, the best d value, and the best q value. Okay. But auto Arima inside the R language is a better algorithm. In Python also we have auto Arima inside PD Arima library, PD Arima or pyramid something, PD Arima, auto Arima, PMD Arima, yeah, PMD Arima. But I have personally tested this. It is not good. But you can see what this does is there are parameters like start P, max P, start Q, max Q, right? So internally what happens is it runs your algorithm for multiple times using different combinations of P, D, and Q value, and then it comes with the optimal P, D, and Q value. So very similar to hyperparameter optimization, but manual hyperparameter optimization is always better. Okay, so hyperparameter optimization, there will be a class next Saturday. Once you are good with this part, you can come back to this Arima code and do the hyperparameter optimization. I have the code here. If you scroll down, there is a code for auto Arima and there is another code for this one. You can see I have already mentioned do not run determine PDQ values. So I'll try to explain the code. I will not run the code. What's happening here is basically I'm trying to run our model on different combinations of P, D, and Q value. Okay. So hyperparameter optimization in a nutshell. Hyperparameter optimization has different steps. One is manual, one is randomized search, and one is grid search. Okay. Now in this case, let's say I am taking my data like this, right? So what's happening is manual search basically means manually you have to call your model again and again. Let's say for p value 1, for d value 0, and q value 1. You run, again you run for p value 1, d value 0, q value 2. And this goes on. This is a tedious process, right? It takes a lot of time to run these algorithms one by one by one, right? Randomized search basically tells you that, boss, if you are giving this, so how many total combinations are possible? It will be 6 multiplied with 3 multiplied with 5. So total combinations possible is 90, right? So out of these 90 random combinations, I am giving you a parameter called as n iter. If you set this as 20, what happens is randomly from these 90 combinations, 20 combinations will be selected and you will finally get which combination is the best. Let's say 402 is the best. That is random search. So the advantage of random search is you can actually give a uh, larger set of numbers, and you can have a control on this number and restrict your randomized process to just have for 20 trials or 30 trials. What is grid search? Grid search tells you that if you are using this combination, so there are 90 combinations, so I will go and run through these 90 combinations and tell you which is the best output. Let's say 402. So obviously grid search takes lot more time, so it is time consuming, but it is a good algorithm. It's a good approach. Okay, so I'm not going through the grid search code. Assuming that our best PDQ values are 40 and 2, I'll go ahead and start doing the prediction part. So here I'm calling the model code. So I'm first dividing the data into training and test. So my training data is 96 records and my testing data is somewhere around 48 records. So let me, yeah, let it be, let it be. So here I am importing all the algorithms. This piece of code is bit complex. I will explain you. So what's happening in this piece of code? Okay. Now, first of all, I already have divided the data into training and test. Okay. So training has 96 records, testing has 48 records, right? So here I am just creating a new variable called as history. This Arima will be over in 5-10 minutes and then I will take the questions. Okay. So here I have taken a variable. So I am putting all the data into history, right? For x for x in train. I have taken another variable called as predictions, which is a list. So by default, it is having a blank list, right? What's happening here is I am running through the list of all the test records. First, I am calling the Arima on history. So imagine you have testing data, sorry, training data and testing data, right? So here we have 96 records, here you have 48 records. So for the first test record, you are taking history. What is history? History is the entire training data. You are taking history, you are calling the model fit, and you are doing the forecasting. And then the output you are storing it in y hat, right? And then you are appending this y hat into the predictions list. So in your predictions, let's say first value comes, let's say 10. That is my prediction. What's happening here is I am appending another record into history. So when I'm doing the testing on the first record, my history has these 96 records, right? When I'm doing the testing on the second record, my history has 97 records. When I'm doing the testing on the third record, my history has 98 records. Fourth record, 99 records. This is what is happening here. So, you're able to get my point? In Excel, let me explain you. Okay? Imagine this is your imagine this is your data. Okay? This is your training data, and these four are your testing data. Try to understand this thing. When I'm running the code first time, my testing data is these four. So this entire data is my history. My history is nothing but from B2 till B9. Okay. What is my predictions? I take all of these records and let's say I predict. Let's say the prediction is 4.77. That is my prediction. So after the first record, my prediction becomes 4.77. So after the first record, when we are going to the second record, what will be my history? My history will be B2 till B10. So now I have this. And then I will be predicting this. Let's say the prediction is 4.79. And to predict this, I take these. You're able to get my point. So in simple terms, what we are doing is we are doing a one step prediction. Okay? We are doing a one step prediction. That means Arima is only doing the very next prediction. That's it. If you ask Arima, uh, like, I want to pass these things and I want to predict four at a one single shot. Is this possible? It is possible. There is something called as Arima steps. Um, Out of sample steps. Arima forecast out of sample steps. There is a beautiful blog on this, how to make out of sample forecasts. So I'll directly go to the code part, which is steps. Steps is not mentioned here. Okay. Anyways, let's go to Google chatbot. I want to. I have a data frame DF with columns date and sales. I want to predict sales for next 7 steps using Arima. Can you write the Python code? So there is something called as steps. I hope it should be able to, yeah, this thing. When you are, because right now we are just doing a forecast. You are not passing anything. That means it is doing a single step. But if you want to do a multiple step, you can usually go for steps equals to 7. Now, I will not recommend you to do that because Arima literally is not recommended for a multi-step forecasting. And that is one of the major disadvantages of Arima. If you do a multiple step forecasting, this will how the Arima forecasting looks like. Like here, the Arima forecasting will be like this. Because Arima forecasts in a linear way. Single forecasting is good for Arima. Like if you want to follow this step, it is completely fine. That means, let's say you are doing a weather forecasting. You are predicting tomorrow's weather. Fine. Tomorrow you are predicting for day after tomorrow. Fine. Day after tomorrow you are predicting for day after tomorrow. Day after tomorrow after tomorrow. That is fine. But today, if you are doing a 7-day forecast, Arima is not recommended. And that is the disadvantage of Arima. You can easily check this out. Right now I don't have the code for steps. What I'll do is I'll try to do a simple multi level forecasting on Arima, and I will upload the code in the same GitHub repository in our ML classes, this thing. Okay, so right now I don't have, and I cannot write a code from scratch right now. It will take a lot of time, but it is really bad. So let me run this piece of code. What's happening here is I explained till here, and then here I'm printing the predicted and the expected, and I'm calculating the error, RMSE. What is RMSE? RMSE is root mean squared error, right? I hope everybody knows this. So I'll run this piece of code. So you can see step by step, it is doing the forecast. This is the actual value, this is the predicted value, actual predicted, and so on. To predict 48 records, it will take like 10 to 15 seconds, and then we will proceed. And one more thing you can see is in the original data, um, it was in the format of hundreds, right? 112, 115, right? Um, 112, 118, 132. But now, as we are doing a forecasting on the um, transform data, that is why the numbers are looking like this, right? So this is not my final transformed data, right? We have to transform it back. So ts.log, this is my test versus predictions on transform data, and then here I'm converting it into numpy.exp, and then if you see, this is how the final graph looks like. And on top of the final data, after converting it into exponentiation to the original scale, my final MSE is 43. So beyond this line, beyond this line is something that I will not cover, but you can run this piece of code to see how it works. Auto Arima is one of the algorithms to provide the different values of P, Q, and D range. And if you run this piece of code, it will tell you which P, D, and Q values are better. So I'm not running this. And you can follow this. And then again, grid search also, I'm not running it. You can run it once you have this code with you. So that's basically Arima for you. As we don't use Arima a lot in day-to-day activities, I'll stop it here. We'll take a very short break, like 2 minutes break. In the meanwhile, I'll pick some questions, and then we will jump into the Facebook Prophet and various other things. Okay, I have a use case in mind, which is Bitcoin use case. I will be doing a forecasting on that using Facebook Prophet and using a regressor, like a random forest regressor or a decision tree regressor. Okay, let's go for a short break, and in the meanwhile, I am checking the comments. Those who have not shared this stream, please like and share it with your friends. Just again, one short announcement is, if you go to the description, I have already given my see, if you want to take my end-to-end AI Masters program, feel free to reach out. And if you only are interested in time series, I have my time series course as well, which is like a 12 hours program. It has multiple things. A lot of things are there which has not been covered in the live classes, and some projects are also there. But as I telling you once again that LSTMs are not part of this program, because to learn LSTM you need to learn deep learning, right? Only if you need to have some detailed understanding on time series you can take. The coupon code is already provided, so you simply can go to the link and then use the coupon code. It should be TSA 399, and then apply. You should be able to get it at 399. Okay, in case you want to go for my AI program, I think I have already talked about this program quite a lot of time, but very few people are interested. it's okay. But just in case you want to learn AI and generative AI, everything, so everything is in this bundle, and the cost is 7,999. There will be an announcement for this program next Saturday. I'm trying to give an announcement. I'm trying to give this course at a little bit lower rates. But yeah, if you're interested, you can reach out. There are multiple things here: machine learning, NLP, deep learning, and computer vision, and then generative AI. Lot of topics are there. Deployments are for multiple AWS, Azure, multiple deployment things are also there. Power BI and Tableau also I have given, even though it's not a part of the AI program. And yeah, live projects, more than 30 live projects. Okay, comments. We'll exactly start in 1 minute. Okay, let me see the comments if anybody has any doubts. Please, sir, there is a recording. I think I already explained this, uh, right? So you can go to my channel playlist. You should be able to see everything here. May I know the agenda is only topic explanation or project? Today's agenda is time series analysis and forecasting with projects as well, right? We will be doing this Bitcoin analysis and forecasting. We will do it right now after people are back from the small break. I think I already answered this. AWS, Azure, GCP, everything is free, but you need a credit card. So only 1 rupee will be deducted when you add your credit card. But after you have done your R&D, make sure you turn off your instances. Let's say I'll show you how AWS looks like. Obviously, tomorrow you will have a better understanding. So let me just quickly show you. Let's say this is my company's account, which is completely fine. So the first thing is you have to start an instance, right? So let's say I started this generative AI instance, right? Under this instance, I can deploy multiple applications. But after your practice is over, always make sure select it and go to instance and stop it. Because if you don't stop, eventually you will, because your credit card is already attached, right? So there could be bills. So initially you will get some one, I think I don't remember exactly, but somewhere around 100 or $200 worth of credits. That's more than enough for practicing. Yeah, hyperparameter optimization is going to be covered next Saturday. So I'm not leaving that topic. So it's going to be covered. Do not worry. Thanks, Bhavesh. Good evening, sir. You said you will be covering 3 algorithms. What about your master's program? I think I already covered this. If you take the end-to-end AI program, uh, your doubts will be like you will cover a lot of things because it's an ocean to learn everything, right? But in my time series forecasting course that I showed you for 399, it's at 10 to 12 hours of program. So obviously you will be learning at least 4 to 5 times more than what is being covered today. But you know, to learn LSTMs, bi-directional LSTMs, you need to learn deep learning. So that's why I don't haven't covered that in the time series program. Hi, sir. Should I learn mathematics? I think I already answered this. It should go hand in hand. If you are picking an algorithm, first learn the mathematics behind it and then do the practicals. Right? That is the best way to learn. But yeah, as Bashir told, try to have some basic knowledge. Just go through my 6 hours of statistics videos, and that I think that's it. You don't have to learn a lot about differentiation and all these things. Whatever has been covered, that's enough. Does Facebook Prophet require to check p-value? I'll come to that. There is in Facebook Prophet. Uh, it's always good to do a stationarity test, but Facebook Prophet does not really bother about stationarity. So I'll talk about that algorithm. But it is always good. Any algorithm you do in the future, if you are doing stationarity test, it is always good. But unlike Arima, Facebook Prophet, LSTMs, checking stationarity test is not mandatory. Can I transform directly even though I have an outliers in my data? Yes, it's completely fine. Outlier treatment and reduction is not mandatory. It's good if you do, but again, in Facebook Profit, we really don't care about the outliers. So Bashir has written stationary test types, sticky fuller, KPSS, non-testated transfer. Yeah, I think you were just noting down the steps, right? What type of method do you use using the last transformation? So the last transformation I did was, uh, what was that? Yeah, I did a rolling window, okay, and then I did logarithmic minus rolling window, moving average. That's what I did. But while creating the model, when I created the model, I used the logarithmic data because for me, doing a inverse transformation is easier for logarithmic data. That's why I did with log. Okay, just to show you guys. Low shortlisting for Power BI developer role apart from any reasons. Oh, this is an off-topic question, Bhavesh. You can reach out to me on WhatsApp later on. I can help you out. If I have a win data for 5 years, are you going to run the 5 years data at once, or you need to do it year by year? 5 years at once. Yeah, 5 years at once, right? See, what I will do, I will tell you. It's good that you popped up this question. So I have 5 years of data, right? I will divide the data into training and test. Simple. So I have my training data, let's say 4 years or 4.5 years, and 6 months of testing data. Okay. Then I will go and run multiple algorithms: Arima, Facebook Prophet, LSTM, blah blah blah. And I will test all of this testing data. And I will check the metrics, RMSE or the MSE metrics. Let's say Facebook Profit is giving you the best results. Then what I will do is I will take the entire data and pass it to the Facebook Profit model to do a future forecasting. Let's say you want to do a 6 months more forecasting. So you can do a 6 months forecasting. So this is the flow, right? Right now, as we are dealing with individual algorithms, I am not showing you this end-to-end picture, right? So I hope it is clear. Now I will try to go to a new code. Let me create a new notebook. I will be using this Bitcoin thing. Um, okay. So let me just upload this file. Coin, Bitcoin. So quickly, let's say import numpy as np, import pandas as pd, import matplotlib.pyplot as plt. What else do we need? What else do we need? Let's say from sklearn.metrics, import mean squared error. What else? What else? What else? From sklearn.ensemble, import. Let's say we will be using random forest regressor, and from sklearn dot, let's say we will also show you how this works on linear regression. Okay. So my imports are done, and then df is equals to pd dot read csv, and then I'm reading the coin underscore bitcoin dot csv, right? So um, let's say I'm first trying to do a plot. Okay, let's say I will be doing a simple plot, plt dot plot, and let's say I'm going to do it on my, so this is my data, right? I'll be using this as one of the features, and I'm going to predict close. Okay, so date and close. So let's say I'm taking date, and then I'm also taking df of close, and then plt dot x label. Let's say I'm giving it as date, plt dot y label. I'm giving it as, let's say, close. Plt dot title. I'm giving it as, let's say, stock price over time. Plt dot show. Plt dot show. Done. So this is my graph. It should be there. Da, 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 da. Time series analysis forecasting regressors. Why it's taking so much time? Okay, now we have this graph, right? Now if you look at this graph, this is how the graph looks like, right? There is a something like this, right? So if I look at the data, how many features do we have? Ignore the S number. Let's say all the data is for Bitcoin. Ignore this, and ignore this. These three are not relevant, right? But apart from that, all of these features are important, right? Except close. Date, high, low, open, volume, market cap. So close is the one that we are going to predict, right? Now, talking about data, talking about date, when you are dealing with a regression problem, ultimately, when you are passing the data to a regression model, you cannot pass the date column, right? Because eventually, date column is in date time. If you remember, if you remember, regression model only takes numerical data, right? So you need to convert this into numerical features. So what all things can you extract from this date column? You can extract the year, you can extract the month, you can extract the date, you can extract the week, you can extract the hour, blah blah blah. Lot of things you can extract. But individually, this date column will not go as a date into the model. Hours can be done, minutes can be done. So basically, here comes the data pre-processing thing. You have to process your data, and you have to convert this date into different segments. So let's say, first of all, I will be converting the date into, let's say, date time, df of date. Now if you look at my date is now a date time, right? Now what I need to do is I need to do a lot of things. Let's say day of week, df of date, um, df of date, dot dt dot weekday. Weekday, not weekday. Weekday is also working. Weekday of week. Let's say I'll just copy paste it. So the second one will be, let's say, quarter dot quarter. Let's say month. Let's say year, month, year. What else? Let's say day of year. Day of year. Day of year, and then Walters. Okay, let's say I'm creating some random features like sine theta and cos theta of these features. So let's say I'll take the day of year. I'll have to do, let's say, numpy dot sine of day of year. Numpy of. So basically, I'm creating my own features from the date column, right? So I have the cos day, which is the cos of day of year, and anything else. I think that's it. Okay, and more features also can be added. So let's say we'll keep it here. And now if you look at the data frame, I have bunch of new features, right? Now, is my date column needed? Of course, I cannot pass this column to the algorithm, so I'll have to ignore this column, right? We already have the important features. We have to ignore the date column. So I will try to drop it. So df.drop. I will pass my date, and then what else? I will delete my s number. I will delete the name, and I will delete the symbol. Okay, so that's my new data frame. After symbol, let's say from my first axis, and then done. My data frame is ready. So df.head, this is my new data frame. Okay, now I divide my data into training and test. So let's say df of year. Let's say before this, df dot year dot value counts. So we have how many years of data? Let's say we have 2013 से लेके 2021. So let's say 2021 data, or both 2020 and 2021. Let's take both of them as my testing data. Okay, so 2023 till 2019 should be my training data. So I'll make it less than 2020 as my df train. So I will divide my training data, which should be df underscore train dot drop, which column I will drop the close column, and then axis equals to 1, and then my y train is my df underscore train uh, of close. Done. And then I'll do the same thing for my testing data. This has to be greater than equals to this has to be my test, this has to be my test, and this has to be my test, this has to be my test. Done. Now I'll check how much training data do we have. 2 for something something. How much testing data do we have? We have 500 something. Fair, right? Fair enough. So training.shape.xtest.shape. So we have around 2438 with 12 columns and 553 with 12 columns. What is the percentage distribution? Somewhere around 3000, somewhere around 18% of testing data and almost 82% of my training data, right? So let's say I'm going to create my random forest regressor. Make it bold. Now I'll call my models. Let's say regression is equals to random forest regressor. Let's say I'm passing my n estimators equals to 1000, or maybe let's say 500 or 400. Again, this is a hyperparameter. Not getting into that. I'll quickly do the fitting with my training data and quickly do the prediction. So let's say my y hat is like dot predict on my testing data. Done. So my model is ready, my predictions are ready. I'll quickly go ahead and mean squared error. Okay. Let's say I'll be using one of the metrics, a simple metrics like let's say mean squared error. Okay, I'll be using mean squared error. So MSC is equals to, or maybe um, let's say root mean squared error. So root mean squared error is the square root of the MSC. One second. Mean squared error, right? Hmm. Okay. Um, mean squared error, and then I'll pass my testing data and y hat data and print my RMSC as RMSC. So my RMSC is around 16,000 something. Now what I'll do is I will do the same thing using a linear regression model. Okay, one more thing that we can do is we can actually plot the graph, right? Um, so, oh, let's generate the code using ChatGPT because I am fearing that I'll not be able to cover the class. So let's say, where is this? I want to have a simple scatter plot between y test and y hat. Uh, write the Python code. Cool, I already have it. Okay, let's take this and then plot it. Y test and y hat. Oh, both of them are in blue, which is wrong because how will you identify between test and y hat? So let me change it. So let's say I'll make it. Hmm. I want y test in red and y hat in blue color. Basically, we'll have to write two scatter plots. One will be for test and one will be for y hat. Yes. So we'll run this. Now we will be able to see the red is not visible actually. It's behind. So it's doing a good job, but the actual and the predicted it's very close, which is weird. It cannot be that perfect. Okay, let me take the example of linear regression and show you how it works there. Same code also we will do it for linear regression. So let's say I'm taking it as a regression one, linear regression. Let me not pass any parameters. Reg one, y hat one, reg one, y hat one. Yes, and then make it one, one. Yes. So the RMSA is pretty low as compared to the original one. Let's try to take the plot y hat 1, y hat 1. No, this graph is not what I'm expecting. So basically, it is having y test in my. No, this graph is not. This graph is not proper. We need to do one second. Y test on my x-axis. I should have. Oh, don't look at this graph. This graph code is not good. See, ChatGPT might not be giving you right answers. This is not good, because in both the codes it is doing the same thing with different colors. That's why you see two different colors latched up on each other, right? This is not correct. Maybe what we can do is, yeah, actually I can. Actually we should be able to do something like this. Let's say the first one is red, and the second one, let's say I do white test on y hat, which is fine, and then color is let's say red, fine. Uh, the second one, let's say I'll make it white test with white test. What this? Hmm. Hmm, hmm, hmm. Yeah, this makes sense. And here, hmm. Yeah, this one makes sense. So yeah, the exact code that has been given is not correct, but this is the relevant code. So you can see that the actual, you can see the blue is the predicted one, right? And it is a straight line because it's linear in nature. And if you look at here, wait, no, both these graphs are wrong. I'll try to fix these graphs. 1 second, give me few seconds to fix this up, because something is wrong. My actual is in red, right? And here my actual, my x data is y test, my y data is y hat 1. So this is not actual, this is my predicted, and this is my actual. Forget about this. And same, this is my predicted, this is my actual. So my predicted is something like this, and my actual is something like this. And for my linear graph, for my linear regression, it is something like this. So, so my actual data is linearly increasing. If you look at the graph, if you look at the original data also, let's say for the year, so let's say I'm taking my filter on the year 2020 and 2021, right? So if I take the close and try to insert a recommended chart only for the year 20, is this for all the years, or is this only for 2020? And 1 second, we are predicting close, right? Yeah. Oh, actually I'm doing the wrong thing. My Excel lagged. 1 second. On the 2020 and 2020. Now, if I do on this, insert a recommended chart. Basically, my graph is like this. Why it is showing me like this? Okay, I'll check on these graphs. Maybe this code is not giving me the right results. Uh, it is actually increasing 72200, and then it's okay. I'll check on this. I'll check on the graphical part, but coding part, I think it's completely fine. There is no issues in the coding part. I'm just deleting these cells. I'll fix this. I'll try to do the fix the code for the graphical part. But so here, my my major input here is we are trying to do a prediction on a time series data, but you can see my date column is not a part of my training data, right? So from the date column, I have actually extracted a lot of information. That is fine. But my original date column is not a part of my training data, or not a part of my features, right? Because if you have date as an original feature, you will not be able to call a regression model. It will fail, right? So these are the drawbacks. Out of these two models, linear regression is giving you better results. It's just because the data is kind of increasing linearly, right? So because of that only you are able to see, uh, it is able to predict the linearity. That's why linear regression is working fine. So we will be taking the same example, and we will be implementing a Facebook Prophet model. Okay, now before going into the practicals of Facebook Prophet, let me just tell you some of the features of Facebook Prophet. Okay, I will also give the link of Facebook Prophet GitHub. This this link is going to give you an end-to-end understanding on Facebook Prophet. Okay, you can go through this homepage. Here they have explained everything. Get started in Python. So each and everything is explained here. What is the Python API that we need to use, and what are the different features. Okay. In a nutshell, let me explain you what Facebook Prophet is. So, first of all, Facebook Prophet, do not worry about outliers. They don't worry about outliers. Second thing is they don't worry about seasonality. They don't worry about seasonality. Third thing is, in Facebook Prophet, you can actually add holidays as a parameter. Imagine you are doing a sales analysis. In this year, let's say Christmas comes same time in all the years, right? So fine, this is fine. But there are a lot of Indian festivals that does not come on the exact same date every year, right? Imagine you have a spike in, let's say, October because of some festivals, let's say Durga Puja. Next year, you have a spike around November because Durga Puja is in November. Next year, the spike is again in October. Now here, even though it is almost a seasonality behavior, but this behavior is driven because of holidays, right? There also could be some spikes randomly because of holidays. 2024, let's say we have one holiday on January 1, on January 26, on some other dates. In the previous year, maybe these holidays are in different days, right? Can we add this to our model algorithm in Facebook Prophet? You can. So holidays plays a vital role, especially when you're doing stock market prediction, right? So holidays plays a vital role because if you are dealing with stocks of an Indian company, so maybe the stocks could be driven by the holidays in India, right? So if you add holidays as a parameter, you will eventually have a better model. So holidays as a parameter is also provided. Another thing is Facebook Profit, you can also add regressors, which means let's say you are analyzing a data or you are doing a forecasting on a particular example. Let's say in our case, let's say you are doing a forecasting on close, right? This is your y variable that you need to forecast, right? If you only pass date as a x variable, that becomes a univariate forecasting, right? You just have one x variable which is a date column and the y variable is close, right? Can we add these, let's say all of these as x variables? Now this becomes a multivariate problem. Can we do that in time series forecasting? Yes, we can do that. So for example, let's say if your data is still here, right? And you want to do a forecasting of, try to understand this thing. Let's say this is your data and you want to do a forecasting for the next record, which is 17th of January 2022 2020. If you want to do a prediction on this, how time series forecasting works, especially in multivariate, try to focus here. It's a very tricky thing. Obviously the model will expect all these values, right? Only when you have all these values you will be able to predict this. So how to get these values? So there is one technique, which is individually you can actually have univariate analysis for high and do the prediction. Let's say you do a prediction, and for low you do a prediction, or for open you do a prediction, and then use these predicted values to predict the close value. That is one way. So in Facebook Prophet, there is something called as add regressor. So you can easily add an existing column or a feature as a regressor to the model. So let's say you are predicting close, you can add these three as regressors. So you will be able to predict the close value. So internally it does the same thing. It predicts all these individually and then use these individual predicted values to predict for the close value. Okay. So that is also there. Another thing I explained to you was holidays, right? Holidays is also there. You can add holiday effects. So if you go to public holidays, right, you can pass a holiday data frame, and when you are calling your Facebook Prophet, you can just pass holidays equals to something like this, and then your Facebook Prophet model will be able to understand that this is the list of holidays, so it will act accordingly. Okay, so Facebook Prophet has a lot of features. Now, as I told you, go through this documentation, you will be able to follow everything. It's super easy. So I'll take the same example, the Bitcoin example, and I'll try to do the Facebook Prophet based forecasting. So to install Facebook Prophet, you need to install two things. So in your local machine, you should be able to have PyStan, and then you can install Prophet. Okay, both of them are needed. So just to pip install PyStan and then pip install Prophet, and you should be able to uh, uh, install both of these libraries. Okay, so here I'm calling the Facebook Prophet, and I'm reading the file, and here I'm taking my y value as close, and then x value as date. So here I'm calling the Prophet model, and then I'm fitting the entire data frame. So here I'm not doing a training and test split. If you want, you can do that. Training and test split is basically done to check how the predictions are behaving with respect to the testing data, and check the regression metrics, right? In this case, I'm not doing that. I'm directly passing the data frame. After that comes the next thing, which is model.make future data frame. So here, another another advantage of Facebook Prophet I forgot telling you is you can predict in any format. That means if you go to any algorithm in this entire world, if your data is a daily data, your forecasting can only be a daily forecast. If you are using a monthly data, then your forecasting can be only monthly forecasting. If you pass monthly data and you want a yearly forecast, that is also possible, right? Because if you want 5 years, so you pass 60 and you can get 60 months prediction, right? But can you go back? If your data is monthly, can you do a daily prediction? No. In any of the algorithms, no. But in Facebook Prophet, yes. Facebook Prophet literally does not care about the these things, like whether it is a daily data, hourly data, monthly data, yearly data. I really don't care. How do you want the predictions? As simple as that. So here, if you pass the frequency as m, it will do a monthly prediction. If you pass the frequency as a, it will do a yearly prediction. If you pass the frequency as t, it will do a minute prediction. Let's say you want to do one prediction per 2 months. That is also possible. Just make it 2m. So you will be able to do one prediction per 2 months. So if you have data till December 2023, your next prediction will be Feb 2024, then April 2024, and then April ke baad, April, May, June 2024, and so on. If your data is till December 2023, sorry, right? So 2m, 2a, all these things are possible. So play around with this code once I give the code to you, and you will be able to understand. Let's say right now, let's say I will do a 6 months prediction. I want the periods as, let's say, 6. That means I'm doing a 3 years prediction, right? So I will do this, not 3 years, 6. Uh, yeah, 3 years, right? 6 months, 12 months, 2 periods, and 2 periods, and 2 periods, 3 years prediction. So now I will do a predict, and then you can see my data was still, if you look at the data, my data was still 6th of July 2021. My data was still here. So this is my first prediction, which is the end of the current month, and then after 6 months, then after 6 months, then after 6 months, and then after 6 months, and then after 6 months. Right? So how many predictions? 1, 2, 3, 4, 5, 6. Okay? So 6 predictions are done. Let's say you want to make it every 2 years, you want to do one prediction. So in this case, you will have 12 predictions, right? So like this, like this, like this. And you will see data was till 6th of July. And then we have the same year last date, 31st of December, then 31st of December, then 31st of December, then 31st of December, then 31st. So that's how you can do the predictions. Okay. So let's say I will do the model plot. This is how the model plot looks like. Components will basically tell you the different components. Facebook Profit, you can see weekly component is also shown, which says for especially this Bitcoin data, every week, there is a spike of values around Tuesdays and Wednesdays. And then every Monday, the value goes down, which is a great insight, right? So I used to do a similar kind of thing with one of my use cases. I think I did one HKD to INR forecast Satyajit. This is one of my projects that I did when I first came to Hong Kong, right? I was getting little bit confused about the conversion rates, and then I had to send my money from Hong Kong to Indian account, right? So usually check out these things like on a daily basis, on which exact date the values are going up. In that date, I can send it back to India. So I that's where I came up with this project, and this is from my own experience, right? I faced this challenge and then I built it. So this is actually a end-to-end project. So you can project later, right? Coming back to this project, here I'm converting it back to exponentiation because if you remember, I did logarithmic transformation and then I'm again transferring back to exp, then model plot, and then here I'm reverting back to the data and I'm plotting a offline graph. Now this is the most important thing. I will download this graph. This is a beautiful graph which you will be able to see. Another advantage of why it is showing like this, one second. um, df df dot tail 10 2021. Okay, where is my final df? Final df dot head. So I have my data frame, date column. I'll answer the questions later. Just give me one second. My TS is here. My Y hat. Where is my Y hat? Oh, actually, the predictions are too much. That's why you can see after 2021, the predictions has gone very, very high because we have done almost a 10 years prediction, right? So I'll go back and change it to, let's say, 6 months or let's say 12 months prediction. And then I will again run these pieces of code. And then I will refresh and download it. Hmm. Done. I so on my x-axis, these are the number of data points that we have. So let's say I'm just focusing on this, the actual. Now, if you look at the actual, we have data till here, right? So we have data till here, and then the predicted upper and predicted lower. So in Facebook Profit, you basically have Apart from predicted values, you also have a predicted upper and predicted lower, which basically means that uh, it is telling you that with 95% confidence your final output will be within this range. So you can say the upper limit is 2995 and the lower is 2 wait the wait, it's completely off. Final df, final tell, y hat. What is the actual y hat? 140, 173. Hi. The predicted is too much. Okay, the actual here is 33.746, so around 33,000. And at the same time, the prediction is around 45, and then the predictions are increasing, right? So, is it a monthly prediction or a yearly prediction? Let me rerun this just for the sake of data because we did a lot of changes here. So, let me just rerun it. Now, no, this is wrong actually. The predictions, the window is too much. So, we need to fine tune this model. So, this is not doing a good job. If you look at the actuals, because still here it is kind of coming like this, and then here it is kind of predicted up. And this is a 1 year predict. Sorry, it's a monthly prediction. So it's the predicted upper is like huge. So we need to fix on these things. But again, I don't have time right now to fix these things. Something is wrong in the model. Let's do one thing. I go to my new Facebook Prophet code. FbProphet on air passengers. Let's say I'll take the same same air passengers data. Actually, I must be having air passengers TS Facebook Prophet model building. Yeah, this is the air passengers data. Let me show this. Yeah, passengers data I must be having. Hmm. And then I take the data. I'm running the same code, exact same code. Here I'm taking 13 months because I want to do a 12 months forecast. So the first record will always be the same month last date, right? And then that's why I'm taking 13 months. And then all these steps, exact same steps. I have not changed anything. So here, if you download this plot, should be able to give you a better visualization on the this thing. Yeah, I mean this is a pretty simple use case. That's why you're able to. It's a sweet use case, right? A toy data set. So you can see that after this particular period, we don't have the actual numbers. So what you see are the predicted values, and Facebook Profit gives you upper and lower. That means it says you that with 95% confidence, we can say that the final output will be in the range of this upper and lower. That is one of the advantages of Facebook Profit. However, with this use case, the results were not quite impressive. Uh, because of multiple reasons, because I have just directly use the same piece of code. So we need to see how to fix these things. There could be some problem in the data set. So yeah, but this is how you you can use Facebook Profit. There are again multiple algorithms such as LSTMs and various other things. So time series analysis and forecasting is a huge module. Covering that in 2 hours was completely impossible, but somehow I tried to explain you Facebook Profit and Arima, and I think your understanding on both of these algorithms should be fine. We'll wind up the class here itself. Tomorrow, same time, 8 o'clock, there will be a live class. Um, it's going to be on model deployment. It's not a live class, as in I'll not be there teaching you, but I already have pre-recorded contents on model deployment. So I'm going to combine that to make it like a 2 hours videos. And please join it live. It will be streamed live only. So I'll give you the link. You can join, and in the meanwhile, you can, you know, do the same steps, and you are good. And deployment is simple, and deployment is same for deep learning and various other topics also. The deployment will be similar. We usually create Python notebooks like this, and then we convert it back to APIs, uh, and then we deploy those APIs. That's how we do. Some of the parameter of Facebook Profit. Yeah, some of the parameters are holidays is one of the parameters, and seasonality is one of the parameters. Because without Facebook Profit, in other algorithms, you don't have a control on different types of seasonalities. In Facebook Profit, you have. So if you are able to master Facebook Profit, literally you can solve any time series problems just using Facebook Profit. That's why learning hundreds of algorithms is not important. If you just focus on one and be a master of it, well and good. Facebook Profit and Neural Profit. These are the two algorithms that you should be master, at least in time series area. If you're good, you're completely fine. You can crack any interview, you can solve any problem in time series space, so nothing to worry about. So that's it, guys. I'll leave all of these links as part of the GitHub. See you tomorrow. Tomorrow we will be, as I told, it will be a deployment class. So we have dedicated videos on Flask um, and project, and then AWS deployment. Everything will be taught tomorrow, and then hyperparameter optimization will be covered in the next Saturday's class, 8 p.m. So that's it. And then I'm going for like 2 weeks of break. I'm traveling. So after I'm back, around. So I'm basically traveling on 10th, but 10th there will be a video that will go, so do not worry about this. So I'll be back be around 18th, and after that from 24th August we will try to have some generative AI project series or something like that. So I'll come live quite often. But yeah, that's it. See you tomorrow. And in case you have any questions, you can reach out to me on WhatsApp for any kind of queries. In case you are interested in taking the AI program, again, reach out to me. Free classes are fine, but if you are serious enough, I will recommend you to take a program, dedicated program, learn everything, practice everything, and then be job ready. Apply for jobs. So yeah, if you're serious enough, you can reach out to me on WhatsApp for the course or any kind of other queries. See you in the next videos. Till then, bye bye. Any other questions? You can use the comment section and you can post it, and I'll able to revert back to you. Thank you. Keeping a note on the comment section right now, there were some comments which I will like to answer. Um, Hello, sir. Can we make AI trading bot by train it with past data and also apply alg? So related to trading bot, I have not made it personally, but some of my Hong Kong students, where I was teaching, they actually their final project was around the same thing. They created a trading bot, and it was working to a certain extent. They were able to they actually made it publicly. I mean, they actually publicly announced it while they were showcasing their demo, the project demo. They made good amount of money from that. So it's possible, but it is not that easy, because stock market trading, and especially stock market data, it is not just dependent on certain features, right? It depends on a lot of things. Even it depends on a simple Twitter post, right? So depends on a lot of things. So it's very complex, but it's doable. For time series, do we use split train test? Yeah, we can do that. Can you use months in categorical format, that Jan, Feb to December only with the Y variable to the time series and forecasting analysis is most to have the date in. Uh, we Yeah, I mean, you can do that. If you are using a regressor, yes, you can do that. But regressors are not meant for time series problems. So time series analysis and forecasting algorithms are always better for time series data. What is the best advice for treating missing values when you have to perform a time series and forecasting analysis? Let's say you have 1980 data for 3 years and you have randomly 180 missing values. So, missing value treatment, in time series, especially, we recommend to use a time series algorithm to fix that missing value. So, let's say 25 records and then the 26th record is a missing value, so you use a time series algorithm to forecast that missing value. That is one option. Another option is Facebook Prophet or any advanced algorithms who really do not worry about missing values. You can try it out yourself. In Facebook Prophet, if you remove this record or you remove this record, doesn't make any sense. Facebook Prophet will still be able to do a prediction properly. So it depends. If you go for traditional approaches, you can use a algorithm itself to do the prediction. The most naive approach will be using mean, median, and mode approach. That is also another way. But the ultimate thing is same. Go to classification or regression or any kind of problem. Eventually, it's the metrics that you need to check to evaluate whether your model is performing good or not. So that is how you can answer whether your model is actually performing well or not. I think I already showed you this. That's it. See you guys. Little bit extended stream for today. As I told you, it's not. It's very difficult. Time series classification I can compress to 2 hours. Regression I can compress to 2 hours. Time series I cannot. But I cannot do a elongated video on time series as well, because you know I'll be very honest with you. I was not at all interested to take today's live class. I was really frustrated from the last few streams. People are not joining. Even if it is free of cost, people are not joining. So then I thought of closing this entire thing. But then I was like, at least some people are watching, right? So at least for them, I should do some justice. So that's why I came live today. So yeah. And tomorrow's class will be a recorded video, but do join. I will be there in the class. I will be able to answer you in the comment section, but it is not going to be a live. It is going to be a recorded live. Okay, so the link will be provided to all of you. If you are part of my communities, you will see it. That's it. See you tomorrow. Till then, bye bye.